for today's class. So we are on our piecewise function. I'm going to just do a quick sketch of number 4 because you should already have that. All right, straight lines. All right, so from like here is where I had a change. So I drew a straight line on the left. It's as straight as that's going to get. And then on the other side, I drew a parabola. Now, since they meet, I'm able to keep that a whole circle. But do you notice that the parabola says only when it's greater than 0? If they didn't connect at the same point, I would have to use an open circle here. However, if I have a closed circle, I don't need to open circle over it. It's just going to say the same thing. So you can make it closed there. Okay. Okay. Hi, Rylan. You can sit over there and get your NWEA stuff out, and I'll get you started in 1 second, okay? All right, what is my discontinuity here? Do I have any discontinuity? Okay, that was at the beginning of 1, 1, or 1, 2. There was continuous. There was removable discontinuity where it was like a hole and then it like continued on. There was one where it didn't have a hole, or it had a hole, but then it like jumped up here. That's called jump discontinuity. Well, it is filled from the other one. So we're going to call this continuous. We call this continuous. Now let's think about domain. What's my domain here? What kind of x's can I have? Good, Lex. Negative infinity, positive infinity. I have an arrow down here, so that means all my negative numbers are okay. I have no holes. I have no holes, and I have an arrow. So every single x is being covered. What about my range? Same. There's no holes here either. Where there should be a hole, there's not, because there's a point there on the other guy. So there are no holes. It's all good. Okay? So if there are no holes, then just yes, they're both positive and yep. How do you know if it's a hole? Repeat the question. How do you know if it's a hole or if it's like a closed circle? You know it's a closed circle if I get to include it. So if it has a less than or equal to or greater than or equal to, then you get to include that point. All right. Why don't you look at the next one? We have to graph that one. Where does it ask about zeros? Of this? Well, where does this cross the x-axis? 0, 0. So what would your 0 be? 0, 0. 0, 0. This is going to be really hard to graph a piecewise in your calculator, so I would do it all by hand. Sorry, I have to get this NWEA up, and then I will talk to you guys. Look at the next one, see what you can think of on that one. Okay, Rylan, your session name, as you see it on the board, it's mute 2032. And then your password is 5765. And then make sure you click your name. There's a handful of kids in there. Oh. Oh no, Rylan, never mind. Get out of there. How do I close that? I did a reading test. Oh no. Oh no, oh no. Suspend. Okay. Can I assign you a new test? Test again, maybe? Gosh, too sad. Can you do something on your side, Rylan? Bring me your thing. I can't do this if I don't know what you're doing. Okay, so you got out. I assigned you the reading test and not the math test, so that was the problem. So it says, let's see. Okay. Let me do this. Maybe I'll end session. Read carefully. So go back. I don't know how you go back. Can you get out of there for me? And now your new passcode is DING, D-I-N-G, 4058. And then 6451. And then yours should be the only name. And it should say math this time. All right, now we're, okay, this looks better. Yep. So everyone enjoy the 10-minute YouTube break. There go all my subscribers. Put it cool. Will, you think I can edit these videos? I just straight drag and drop from Zoom. It says save this recording, I rename it, and I just drag it into YouTube. Anyway, so for everyone sticking around and for everybody in class, let's continue onward. Sorry for that brief intermission. I just was an idiot and couldn't do that right the first time. Okay, so we're back on this next one. We have another piecewise. I have the reciprocal function if x is less than 0, and I have the square root function if x is greater than or equal to 0. Okay, so let's focus on the reciprocal one. So I want to draw a graph. There's my graph. This is not where I want higher. That's fine. Okay. And I need to graph the reciprocal function where x is less than 0. That's over here. What does that look like over here? What quadrant is it going to be in? The bottom one, and it's kind of like a C curve, right? Going all along the axis. So I'm going to do that in this like big green color. I just want a C curve along the axis in that third quadrant. That is my 1 over x graph. So I did that piece. Now I'm going to do the next piece. And this one is a square root function where x is greater than or equal to 0. So when I did my little highlight box, I'm going to include 0 this time. I have to graph my square root function. What does the square root function look like? Good. It's like a sideways parabola, just half of it. It goes through 0, 0, and it kind of curves up like that. Since it says greater than or equal to, I get to have a closed circle on 0. And that's my. Say again. The what? The what only matters. The the inequality sign matters if there's a point on that line. Yes. So you saw how this one, if this one even said equal to, it wouldn't change our graph, right? Because we can't put a point that's equal to. Very good question.
And then I was wondering for the reciprocal one, I thought it was one in that quadrant and then one that was like symmetric to it or like on the opposite.
Right, but I'm only going to draw it where it's less than 0.
Oh, okay. Thank you.
You're welcome. Okay, now let's talk about what kind of discontinuity this is. Is this a removable one where I can just fix it with a point? No. Is it a jump?
Yes.
It kind of looks like a jump, but I've got one better.
Infinite.
What? Infinite or non-removable. Those are the same ones. I would call it infinite or non-removable. Because it's like a reciprocal one or infinite discontinuity. It's my discontinuity.
Why is it removable?
It is non-removable because I can't like fix this. Like it has an arrow down here. I can't like pick up this graph with like my like scissor tool and like move it and fix it. So because that's not how it works.
It's all its own.
Yes, it's all its own kind of graph. I think we'll see one like a jump one in the next one. So we will talk about that in a second. Infinite discontinuity. I just didn't feel like spelling it all the way out. Now let's think about domain and range. What's my domain? Or maybe rather what's not in my domain. Is there anything not in my domain? Remember, domain is x's. It's hitting all of them here. It's hitting all the negatives over there.
The positives.
It's hitting all the positives.
All real. I don't know.
This one is going to be all real numbers. Even though we have a gap on my graph, if you had a normal reciprocal function, the only thing that's not included is 0, but I have a point at 0. This is going to be all real numbers. If it was open, it would not be all real numbers. It would be everything but 0.
Is that when you do the zero?
It'd be like negative infinity to 0, and then u, 0 to positive infinity. All right, what about range? Similar idea, right? I would say all real numbers too, because this is going to approach 0, and then this hits 0, and then it goes up and up forever. Ooh, that was cool. I'd say all real numbers again. All piecewise functions are just little pieces of other graphs. So you need to break it apart smaller and smaller. This is the last one we're going to do together. So if you still struggle with piecewise, it's not on the quiz this Friday, so I guess you don't need to know it by Friday, but you need to know it by the time we take the test. I'm going to tell you that right now. There's for sure a piecewise on your test. So let's do this last one. This one has 3 pieces, so we're going to have 3 kind of boxes on this. So I'm going to draw my little graph. And it says that I have a function that goes from x is less than or equal to 0. Okay, so I'm going to do a little box over here that includes 0 and then everything less than it. Then I have a box that goes from 0 to 1. It doesn't include any of them, 0 to 1. So I'm going to say that's like here. And then I have another one that goes from greater than or equal to 1, so anything bigger than 1. If you don't have, if it's not on your iPad, if it's on paper, I would just do kind of hash marks. So I kind of do one of these guys. I'm like, all right, here's a mark, and then here's another mark. But that's messy for me. If I have nicer tools, I'm going to use a little bit nicer stuff. Okay. So let's take it one piece at a time. Let's do the yellow box first. It says in the yellow box, we're graphing -3 minus y. What's that going to look like? A what? -3 minus x? A line. That's all I'm looking for. A line. Good, Grace. A line. So I'm going to draw a line. This is in y equals mx plus b form, right? What's my y-intercept? -3. What's my slope? -1. Tried to trick you there with the x in the back. That's why we practice some harder problems than what you would see on a quiz or test. So I'm going to graph -3, 1, 2, 3, and I'm going to go down and then to the right, but I can't do that. So I have to make a negative slope somehow. So I'd go up and then to the right, or to the left, up to the left, up to the left, up to the left. Remember that it has to be a negative slope. So if you end up graphing it and it's not negative, then we'll have a problem. All right.
And even though it's a negative slope, it goes up.
Well, as you read it across the page, it's going down, right?
Oh, right.
Mm-hmm. Remember, if I'm talking about increasing and decreasing or going up and going down, it's how I read it across the page. So as I go from left to right, as I go this way, it is going down the page as I move from left to right.
It goes, yeah, from the top to the bottom. Okay.
Yes. All right, now let's graph the pink one. It says I'm graphing the function 1 between 0 and 1. 1, there's no x there. What's that going to be? 1, what's my shape going to be? What am I going to draw? It's going to be more than a line other way, Chris. It's going to be a horizontal line. If it's just y equals 1, that's just a horizontal line through the point y equals 1. Now, I do not get to use closed circles because it says it's less than 0, or sorry, it's greater than 0 and it's less than 1. So I'm just going to do an open circle and I'm going to do a horizontal line across. I know it's at 1 because it says it's y equals 1. Well, 1 on the y-axis because it says y equals 1. 1 on the x-axis because it says it goes from 0 to 1. If you want to, you can graph the whole thing and then erase the parts that it's not in. That usually, to me, though, gets confusing if you don't remember to erase it all. So that's why I don't always do that. The last one says it's x squared if x is greater than or equal to 1. So I need to graph a parabola over here in the green space. I can't just start at 0 and then graph like that because that's not what a parabola is at. It doesn't start at 1, 0, does it? It starts at 0, 0. I'm not allowed to graph it in the pink though. What would it be when I finally enter the green box? It will be what? Good. It'll be at the point 1, 1. Whoa, sorry. If I'm not sure where it's going to be, think about, okay, I have x squared and I want to make it where x is 1. Well, what's 1 squared? 1 squared is 1, so my coordinate point would be at 1, 1. Now you can parabola from here. Again, what you can do, I'm trying to give you some options so you don't feel like helpless. Oh, that's not what I wanted to do at all. Okay. What you could do is you could graph all of these independently. I could be like, okay, here's what a parabola looks like. Here's what y equals 1 looks like. And then here's what my equation of my line looks like. You can graph those all by themselves and then be like, okay, well, I'm only allowed to have the line if it's less than 0. And then I'm going to take my little eraser and I'll be like, okay, erase, 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 blah, blah, blah. So that it's just this line over here. I'm doing a poor job with my eraser, but do you see what I'm doing? So you could graph that normal line and be like, okay, well, it's only allowed to be here, so let me erase it everywhere else. Same thing with the y equals 1. You could say, okay, I know it's only supposed to be in there, so let me erase all of this over here, and then all of this over here. And then same thing with the quadratic. You make, okay, well, I only know it's supposed to be on the other side, so let me erase all of this stuff over here to get what you need to do. It's just going to mess up my graph. I'm not doing too much erasing. Okay. Questions? You're just graphing 3 different functions on the same graph. That's all it is. This is a really good thing to practice. So if you are having a hard time with this, you either need to come see me or you need to put in some work on your own. Okay? Gotta hit the gym with piecewise functions. Okay. All right, let's do our discontinuity while we're here. This is so ugly. I wish I hadn't drawn that. Oh well. It's mostly gone. Okay. What is my discontinuity here? Is it continuous? No. Is it a removable discontinuity? Is it just one point that's out of place? Is it a jump discontinuity? Yeah. Think about it. If I wanted to pull this all the way up here, it would work. It would fix my problem. So I'm going to call this jump discontinuity. Ooh. And then let's talk about my domain and range again. All right, as we're thinking about x's, I have an arrow over here, so that means I've got all my negative x's. I go all the way down, I hit 0. Okay, I've hit everything up to 0. I have an open circle, but then I immediately keep going. And then I have a closed circle, and then I have an arrow. Did I miss any x's? Did I leave any x's out? What did I leave out?
0.
I have a point down here at 0. Say again? What? 0, 1? Well, I left him out, but I have him down here. I have a 0 point there. Mm-hmm. It's all real. When did what circle get filled in, Lux? Which one are you looking at? Yes. Good. I filled this in when I did this one. So I'm going to say my domain is all reals. The range is where we're going to have some issues. Range. Let's talk range now. What's my smallest y value you see? -3. Everything else is bigger than that. That arrow goes on and on forever, so that means I hit everything. But even if it didn't, this has an arrow that goes on and on forever. It hits everything. The only problem with my range is that I don't go lower than -3. So -3 to infinity. You know why I can include -3? Oh, so I still have y's at this value, right? I still have y's there. Here's a y, here's a y, here's a y, here's y. All those are y's at 1. So there's nothing I'm missing out there. Okay, I'm sorry that wasn't all cohesive. Maybe this would have gone easier if we had done all of them in the same day and I didn't have a break. But again, if you have questions, come to me. Is this on the quiz on Friday?
No.
No. Is it on the test next week? Yes. Okay, good. Glad we're on the same page. All right, now we are officially done with 1-3. So now that homework is due on, what day is it? Wednesday? It's due on Friday, day of the quiz. 1-3 is due on Friday. Let's go to 1-4. Functions. We are doing operations with functions, and I think this is the easiest thing we're going to do this unit. Personally, I think that. I have, at the very top, I've got labeled functions. I've got f of x equals 3x plus 2. I have g of x equals x squared plus 1. I have h of x equals 2x. And I have p of x equals square root of x. Anytime I refer to f of x, I want you to use that. Anytime I refer to h of x, you use the h of x. So the first one said f plus g. I'm just going to physically add my two functions. I'm going to add 3x plus 2 plus x squared minus 1. I'm just adding them together. Remember to combine like terms and remember to put your variables from like biggest to smallest. So I'll go x squared plus 3x plus 1. Alan, you all done? Is this, nope, this is somebody else's pass. Can I write you a pass to class?
I don't think you need to.
Oh, okay. Is it just resource?
Yeah.
Okay. If you need something, send me an email. All right. Okay, then it asks for my domain. I heard it. What'd somebody say?
What?
I heard somebody say anything. That works. Is that you, Abel? Is that you, Grace?
No, I don't know. I wasn't.
I thought someone said anything, and I said, okay. You can do that. Was Chris? Awesome. Thanks, Chris. You're doing a great job of throwing your voice, man. It's all real numbers. You can square anything. You can multiply 3 times anything. You can add 1 to anything. Any number works there. All right, next one is h minus f. Am I going too fast or are we doing okay? Okay. I have half the class falling asleep and the other half has no idea what's happening. And there's a quarter that's the same. H of x is 2x and f of x is 3x minus 2. What am I going to tell you to do with this problem? You're going to have to distribute that negative. Don't forget to put parentheses around it because it's so easy for us to forget, and then you're going to get a wrong answer, and then you're going to be sour grapes if you got the wrong answer.
So you can't.
Yes, yet? No?
I have a quick question.
Yeah, Kirsten, what's up?
Are you not allowed to have a negative x in this equation?
In the one that we just did?
Mhm.
Letter A or letter B?
A and B.
You can have negative x's
Okay.
because you can square a negative, right?
Yes.
Mm-hmm.
Well, then why do we have to put the parentheses around the? Oh, because it. Because we had to plug in f.
Because we're minusing f, and if you don't do the parentheses, you'll forget to make that 2 negative. I'm not just minusing 3x, I'm minusing the entire function of f.
Okay, the entire function of it. Let me circle that. Okay, thank you.
You're welcome. So now I can simplify that to be negative x minus 2. Is there any problem with that? Nope, all real numbers. Ooh, that's not how I write that at all. It's just, okay, remember what causes problems in domain? Holes, and what makes a hole? A fraction. If there's an x in the denominator, that causes a problem. And then there's one other one that we did all of our domains. What was a common thing I had in your domain problems? Square root. Those are really the only things you have to worry about, is if it's a fraction, if it's a square root. If it's just a normal function, you can plug any number in there. I can do anything times negative 1 minus 2. It will not be a problem. Okay, now I'm about to multiply. We'll see if that gets things a little funny. F of x times g of x. So if I have this little sign right here, that just means multiply. Okay, let me time out. Have we seen something like, have we done this before? This is algebra 2 stuff, right? Okay, I'm not saying that like we're gonna not talk about it. I'm just saying like we've seen it before, so I'm not going out of my way to explain like f and g are the functions of f of x and g of x, right? We're all okay with that? Okay. I'm going to assume that we still retained very little from algebra 2. That assumption hasn't changed, but I do think that you've seen this before, right? Okay, just had to confirm. So if I have a multiplication sign, I'm going to multiply f times g, so 3x plus 2 times x squared minus 1. Don't forget to put parentheses around these so you can FOIL this. Multiply, 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 multiply. 3x squared minus 3x. Oop, 3x to the third. Not paying attention there. minus 3x plus 2x squared minus 2. Do I have any like terms? Nope. I would like you to rewrite it though to do 3x to the third plus 2x squared minus 3x minus 2. Make it look nice. That's all I ask. All right, what's my domain for this one? All real numbers. There's no fraction, there's no square root. We can do this all day. Hanging in there? No? What part? Okay, so we're just, okay. Good. Now I'm gonna do h of x times p of x. So I haven't looked at those yet. I'm gonna do 2x times radical x. You can't simplify that anymore because I cannot multiply 2x times something in the radical. It's just going to be 2x times radical x. Ooh, domain on this one. What's the problem here? Square root. What cannot be under the square root? A negative. What's the smallest thing I can put under that square root?
0.
0. 0 is the smallest thing I can put under it. I can put anything bigger than 0 under it. We doing okay? All right, last one. H divided by f. 2x divided by 3x plus 2. You cannot simplify that. You can't do anything more with that. I just want you to leave it like a fraction. That's fine. That is a fine answer. That being said, what's my domain? What's going on? The bottom cannot equal 0. So if I set this equal to like not 0, we start solving, right? Minus 2. Divide by 3. Good. X cannot be negative 2 over 3. It can be literally anything else except for negative 2 over 3. So I'm going to go write my domain is negative infinity to negative 2.2 over 3, and then negative 2 over 3 to positive infinity. Don't forget, it's all parentheses because I cannot include negative 2 over 3. That is the problem. That is the problem that I have. All right, that was just doing our basic operations: addition, subtraction, multiplication, division. Now we're going to do something where we call composite functions, or composition of functions, I guess. A composition of functions means that I'm using two functions and putting one inside of the other one. I can use brackets. I can use a little like O symbol essentially to do that. And then I can either leave it as an X or I can plug numbers in. So we're going to do a couple examples and kind of see how this looks. I'm still using the equations from the top, F, G, H, and P. So this first one says that I'm going to do P of H of 1. I'm going to plug H into P, and I'm going to plug 1 into H at X. Let's take it one at a time. Okay, if I have H of X is 2X and P of X is root X, I'm going to take 1 and put that in for my X of H of X. So I'm going to do 2 times 1. Then I'm going to put my H of X inside of my P at its X. So that means I'm going to replace X under the radical with 2 times 1. I'm going to just put a radical hat on top. You could have built it the other way if you wanted to. You could have said, okay, I'll write that back down in a second. You could have said, okay, it looks like I have P, and then inside of its X is H. So inside of the x of p is my function h. So I'm going to do radical 2 times x. But I'm not doing h of x, I'm doing h of 1. So inside of my x of h, I'm going to replace that with a 1. And then I just simplify. 2 times 1 is 2. Radical 2. My answer. All right, questions? Moving on, next one. Now I'm doing h of f. H is the first one, so it's on the outside, and f goes inside of h. So what is f? F is 3x minus 2, and h is 2x. So 3x plus 2, 2x. I'm going to put f into h. I'm going to put it where the x is. I have f in the green, and then I have h is my 2x. I'm going to plug in 3x plus 2 into my x for function h. One more thing I have to do is I have to do 2 into my f. So I'm going to replace the x with 2. Are we doing okay on why I'm plugging things in? Okay, I'm going to take that deafening silence as if we're doing okay.
Well, I have one quick question. What is the little O part again?
The O is like, it's of, so that you read this as H of F. This is an algebra 1 thing, or algebra 2, maybe even an algebra 1 thing. And it just means we're doing the composition. So the little O means that F goes inside of H.
Oh, okay, okay. Goes inside. Okay, thank you.
You're welcome. So let's simplify this. I have to do my inside. 3 times 2 is going to be 6. 6 plus 2 is 8. 2 times 8 is 16. All right, and then the next one says h of f of x. You can tell me what to write. You plug f into h. So h is on the outside. H is my 2x. So I'm going to have 2 times something. And f goes on the inside. So I'm going to go write f inside that parentheses. 3x plus 2. Yep, and so since x is already x, we don't have to replace that with anything. Very good. So instead of putting a number in for x, I'm just going to keep it as x. And then now I just simplify this. I want to get it down to the most simple term, so let's distribute 6x plus 4. That's it. All right, we're going to skip D because FG is just F times G, and I don't think I meant anything different. It would be the same as this, and if so, I'll address it next time I see you. So we're going to skip that one for now. We're going to talk about implicit functions. Actually, no, we're not. We're going to skip to number 4, and we're going to do we just did composition, so we're going to do backwards of composition, and if we have time, then we'll do some more implicit functions. I think you are fully capable. I think there's room in your brain. You only know how to do the first one of these? Of what graphs? You only know how to do the first one from piecewise? Anything after piecewise? This is the easiest stuff we've done all unit. Just add and subtract. Maybe if you stop texting, you would understand. Yeah, you just stop paying attention. It's not that hard, I promise you. I promise, guys, this unit sucks because it starts hard and I promise it ends easy, but you're so sick of it being hard that you're just like, you are not even trying sometimes here. So just let everything sit aside. Focus on this last little bit. We're doing a decomposition. So that means this is my function, 2x minus 1. And I want to break it apart so that I have one function on the outside, f of x, and I have one function on the inside, which is g of x. So if I was given 2x minus 1, I need to break that apart to be an outside and an inside function. Um, 2x minus 1. F of x, g of x. Well, it looks like it's like on the outside of this function. 2 looks like it's on the outside. I think this is more easy or easier than you think it's going to be. 2 is being multiplied by x. I have 2x plus minus 1. I have x is like the variable, it's on the inside, and then around it I have 2x minus 1. I think one way you could break this up would just be my inside function is just your x, and then your outside function is your 2x minus 1. I just plugged x into that. Normally it's more complicated. I don't know why we're given such a terrible example. That's right, the next one's a little better. G is just x. Yeah. So when I plug x into x, it doesn't become x times x. X like replaces that x. Or I guess we could use this. We could use it as a y. We could relabel that as y. A different variable if that makes you happy. It's almost too basic. The next one I think makes a little bit more sense. All right, what's the outside function on letter B? What's the big outside function that something's being involved in? The exponent, that's square, right? So the square is the outside function. And then what is being squared is my inside function. So what's being squared?
X plus
2. Good. So if I were to plug this in, if I were to go backwards, let's say I had started here instead and I said, okay, find me f of g. We would say, okay, well, I'm going to plug g into f. I'm going to plug x plus 2 into my x squared. That's all that it is. I replace it with my x squared.
Actually, could we like go back up to the A really quickly? How do we know that 2 x minus minus 1 was on the outside?
So there's no parentheses in this one like there is in letter B. So I'm assuming that 2 minus 1 is on like the outside of the function and that x is just what the inside function is. There's not more to break apart. So this one I think is kind of a poor example. I'm going to make another one up. So let's do that. Let's call it this. Let's do 3 radical x plus 7. What's on the inside of that? What's inside? I'm going to argue even just x plus 7. And then what would we think is on the outside of that function? 3 radical x, right? So on the inside is what's just in the radical, that x plus 7. And what's on the outside is 3 radical. Now I can't leave the radical empty. I have to put a variable in there, which is why I'm going to put the variable x in there. But when we do our composition, I replace that x with the x plus 7. Essentially, when we do decomposition, which is what this is called, I'll zoom back in a second. This is decomposition. Basically, I'm breaking down what we just put together. So I gave you an equation that I like threw everything together, and now we're breaking it apart into the 2 functions it is. Okay. Is that a little bit better? I'm sure there's
It's
a
like-
on your homework like this. So I would look at that in, now again, not for Friday, but for the future. Look at that and see if there's a good example there. Okay, let's flip back. Let's do a couple implicit functions. Implicit functions refers to the fact that I'm going to have two functions come out of this. Two functions. Remember last week when I told you if we had an x squared, that's not a function because you have a plus or minus? What we're finding here is that if I wrote them as two separate functions, one's the plus and then one's the minus, we call them implicit functions. It's not a normal function, it's called an implicit function. It's implying that there are two of them. So when we see an implicit function, we're going to solve for y. Okay? What's my first step to solve for y here? Move the x, minus x squared. So y squared equals, what are you doing? Yep, okay. Equals 25 minus x squared. Okay, how would you get the y all by itself? Yep, square root, radical, square root, square root. That gives me y by itself, but it's going to give me plus or minus radical 25 minus x squared. Because it was an x squared on the other side. Oh, okay, good question. Because 25 and x squared are being subtracted, they're not being multiplied, you cannot simplify that. Good question. Did everyone hear Grace's question? Because we all try and do this and we all get points off. You cannot simplify the x squared, you cannot simplify the 25 because they are being multiplied, or they're being subtracted, not multiplied. If they were being multiplied, you could simplify that. You could take out a factor. Okay, the implicit function follows. I just split it into two functions. One of them is y equals positive radical 25 minus x squared. And then the other one is y equals negative radical 25 minus x squared. Those are our implicit functions. Individually, they are a function. This is a function by itself because it passes a vertical line test. And this one's a function by itself because it passes a vertical line test. When I write them together like this, it is not a function because I have a plus and I have a minus, which is causing me a problem. Okay, shall we do another one? Awesome, I can't wait either. What do I do first? Subtract the x. This problem is almost the exact same. Except it's not x squared, it's just x. And then what do I do? Square root. Oh, I guess I already did the square root. I'm going to have a y equals positive root 25 minus x, and I'm going to have a y equals negative root 25 minus x. That wasn't too bad, was it? We're going to end 2 minutes early. Why did we what? Because I needed to do other stuff first.
Help me
Yeah.
right now. My brain is
Let me-
getting jumbled.
Let me stop this recording.